This is lecture number 3. In lecture number 2, we have seen the transfer function. What is meant by transfer function and what are the advantages of transfer function, and I took a problem of RC circuit. I got a first order transfer function. In this lecture, I'll continue the same lecture. There is a called transfer function. Transfer function. So in this case, I'll take an example number 2, that is to find transfer function TF of a below shown figure. So in the figure he has given, there is a tank, and here there is a valve. Here the output discharge Q0, here input discharge is Qi, and the head of the water or head of the liquid is H of T, because I can vary the input and the output is Q0 of T, the variation in the discharge. And R is the resistance at the wall. Okay, maybe minor loss, major loss, friction loss, resistance at the wall, or R. Q0 is the discharge, meter cube per second, and inlet discharge is also meter cube per second. A is the area of cross section of the tank. Now, the transfer function, you know the definition of transfer function, that is Q0 of output, Laplace of output divided by Laplace of input. That is a question mark. I supposed to find Q0 of S divided by Qi of S. Here I cannot apply Kirchhoff's second law, or I cannot apply Newton's law. Here I have to apply, if it is a fluid mechanics problem, then I have to apply the discharge. The inlet discharge is equal to outlet discharge, and the remaining water is stored in the tank. For example, always the Q0 is now, in this case, Q0 of T is lesser than Qi of T. This is assumption, and more practical way. And here, due to this, presently the instantaneous head is H of T, but after a certain period of time, definitely there is a increase in head, dH of T. Definitely the height will be increasing, dH of T. And area of cross section, now I will apply the Qi of T is equal to inlet discharge is equal to water stored or liquid stored in the tank, dA dH by dt, because it should be meter cube per second, because Q0 is also meter cube per second, Qi is also meter cube per second, A dH, because A is meter square into meter per second, that is meter cube per second. This is also meter cube per second, this also meter cube per second. A is the area of cross section of the tank, and dH is the increase in the height or change in the head of liquid with respect to particular time. Now it is a differential equation. The Laplace will help us to convert differential equations into simple algebraic equation. We know d by dt is S, and d square by dt square is S square. Okay, now I will apply the Laplace transformation to this equation, that is Q, and I becomes T becomes S. So Qi of S equal to A d by dt is S. Yes, H of T becomes H of S plus Q0 of S. Here, but I want Q0 by Qi, so Q0, I cannot take a Q0 is a common, so that this is an intermediate variable, that is intermediate variable output. I don't want intermediate output, I am interested in the final output, so that I will remove the H of S. To remove the H of S, I required one more equation. So what is the one more equation? Suppose say this is equation number 1, and one more equation, the outlet, as per Bernoulli's equation, the outlet discharge is directly proportional to the head. If head is more, velocity of the liquid will be more and discharge will be more. Q is equal to AV. So now the Q0 of T is directly proportional to head of liquid in the tank, or height of liquid in the tank. So if I remove the proportionality is equal to h of t divided by inversely proportional to resistance, the discharge. If the resistance increases, discharge decreases. If the height in the tank is increases, discharge is increasing. So now I'll take a Laplace transformation. Q naught of s is equal to h of s divided by r is a constant, because you cannot apply the Laplace for constant. So h of s is equal to r q naught of s. This is equation number 2. Now you put equation number 2 in 1. You put equation number 2 in 1. Now I'll get qi of s is equal to a. H of s is r q naught of s plus q naught of s. Now I'll take a q naught of s is common, that is a r s plus 1. So this is qi of s. Ultimately the Laplace of output divided by Laplace of input is equal to 1 by a r s plus 1. Exactly it is similar to in the previous class, the transfer function of RC circuit resistance and capacitor circuit. Both are equivalent. Both are equivalent, that is the electrical, and this is what? Mechanical. Now AR is the area of cross section of the tank, R is the resistance. I can write Q naught of s divided by Qi of s is equal to 1 by TR, Ts plus 1. T is equal to AR, that is equal to time constant in second. There also there is a time constant T equal to RC. Both are same. This is also the highest power of s in the denominator. You don't see the numerator, otherwise irrespective of the numerator, you see in the denominator the highest power of s in the denominator is how much? 1. So it is called first order system. First order system. It is similar to RC circuit. Similar to RC circuit. I hope you understood the question and answer. The question is to find the transfer function of a below system. The tank, the liquid tank system. In the liquid tank system, the Q naught of s by Qi of s equal to 1 by Ts plus 1, T equal to AR. A is the area of cross section, R is the resistance at the valve, or resistance in the system, that is equal to time constant. Okay. So I'll move to the next question, that is what? Double tank, the cascade. Two more problem I can generate. One is a parallel and one is a series. Okay. Next question. Next question. Find transfer function TF of a given below figure. Okay, usually, okay, this is a problem. He has given, very interestingly, he has given two tanks, one and one more tank below, and here R1, R2, here Qi, and here Q1 intermediate discharge, and here H1, and here that is H2 of T. Area of cross section of a tank may be varied. This is A1, this is A2. A1 and A2 are area of cross section of the tank. This final output is Q naught of T. Here there are two tanks. The tanks are in parallel, not in series. If it is a series, a lot of complexity. It is a parallel, it is independent. Parallel classes are going on. Anybody can leave first, anybody can leave second, no issue. If it is a series, first lecture if I leave late, then the second lecture is also becomes late. Everything will be late. That is a different problem. So here, ultimately, what is my question? To find a final output Q naught of s divided by Qi of s question mark. This is what I supposed to find. Final Laplace of output divided by Laplace of input. Okay, intermediate output is this intermediate output, it may be intermediate output. There are output 1, 2, 3 and total is 4 output and single input, but I want final output. So this is the question. So I'll take a consider first how to solve this problem. Solution, case 1, consider first tank. Independently you can first tank because these are parallel. If it is both are series, then it is very difficult to consider first tank and second tank. Okay, so in the first tank you know that already I solved in the previous problem. Directly I can apply the rule, that is h1 of t. Okay. So directly I can Laplace of output, directly I can write a transfer function qi of s is equal to 1 by t1 s plus 1, and t1 equal to what? I'll write a1 r1, area of cross section of a tank, r1 is the resistance. This is equation number 1. I can write directly. Okay, and next I'll consider the second tank. Case 2, consider tank 2. In the tank 2, the Q1 is an input, that is Q1 of t, that is the output of first tank. This is R2, this is what Q0 of t, and this is what H2 of t. Okay. Here also I can write Q0 of s divided by Q1 of s equal to 1 by T2s plus 1. So equation number 2, and T2 I can write A2 R2, time constant. T1 and T2 are time constant in second. Now what I have to do? I have to multiply equation 1 and 2. You'll get the answer. Very simple. So now I'll write multiplying equation number 1 and equation number 2. Equation 1 and 2. Equation 1 and 2. Okay. Now I'll write Q. What is the equation number 1? Q1 of s divided by Q0 of Qi of s is into Q0 of s divided by Q1 of s equal to 1 by T1s plus 1 into 1 by T2s plus 1. Now Q1 get cancelled. We'll write Q0 of s divided by Qi of s equal to 1 by T1s plus 1 T2s plus 1. If I remove the bracket, T1 T2s square plus T1 plus T2s plus 1. So it is definitely different from the previous transfer function, because here the power of s in the denominator is 2, so that it is called what? It is called what? The power of s in the denominator is 2, so that it is called second order system. You don't see it in the numerator. Irrespective of the numerator, you see in the denominator, it is called what? Second order system. Okay, so we will take one more problem of a second order, because first order we took 2 problems. Second order also we took 1 problem I solved, and one more problem I solved based on electrical system. It is called a hydraulic system or fluid mechanics system. Now I'll take one more problem on electrical system. So find a transfer function of RLC circuit. Find TF of a RLC circuit. Very important circuit. RC and RLC are two basic circuits and important circuits, RLC circuits. So, solution, first you draw a RLC circuit. R, L is the inductor and C is the capacitor, RLC, and VI of t, I of t and V naught of t. Because t, why I have used, I can vary the input with respect to time, so that current is also varying and output is, voltage is also varying, but RLCR remains constant because resistance, neglecting temperature effect, okay, you have to assume no change of resistance with respect to temperature, even inductor and capacitor. Okay, now here I have to apply what? I have to apply Kirchhoff's second law. Input voltage is equal to voltage across resistor plus voltage across inductor plus voltage across capacitor, neglecting all the losses. So that I will write VI of t, input voltage is equal to voltage across resistor plus voltage across inductor, L di by dt, plus 1 by C integration of I dt. All three are resisting elements. All three are opposing for the flow of current. Like spring, mass, damper. Like inductor is nothing but mass, and capacitor is nothing but spring, and resistor is nothing but damper. And the input voltage is nothing but force. Current is nothing but displacement of the mass. Analogy between mechanical and electrical. Now, it is a differential integral equation. How to overcome the differential integral equation? By taking a Laplace. You know that the Laplace of d by dt is 1 by s, and d by dt is what? Yes. Okay. You know the Laplace formulas. Now I'll apply, and t becomes what? T becomes s. Now, taking a Laplace transformation, Ri of s plus Ls I of s, because d by dt is s, I of t becomes I of s, 1 by c, integration of dt is 1 by s, I of t becomes I of s. Now, I'll take a I of s is a common, R Ls plus 1 by Cs. So, LC s square plus RCS plus 1 divided by Cs into bracket I of s. This is equation number 1. I have to remove the what? Current, intermediate variable, because in the question what he has asked, find a transfer function means Laplace of output. This is output, Laplace of output. This is the input, Laplace of input. This is nothing but transfer function, question mark. So here no V naught of term is there. I have to substitute V naught of term. What I have to do? I will write one more equation. You know that in the RC circuit also I have done the same thing. The output voltage is nothing but voltage across capacitor. So one more equation I can write, output voltage is equal to voltage across capacitor, because here capacitor is there. Now I will take a Laplace transformation. So once again, V naught of s equal to 1 by c, integration of dt is 1 by s, and I of t becomes I of s. So I of s equal to V naught of s Cs, equation number 2. Put equation number 2 in 1. We get the answer. So now equation number 1 is this. So Vi of s is equal to LCS square plus RCS plus 1 divided by Cs into I of s becomes V naught of s into Cs. Cs get cancelled. V naught of s, Laplace of output divided by Laplace of input, is equal to 1 by LCS square plus RCS plus 1. It is exactly similar to the previous problem, that was what? The tanks are in parallel. There also what? T1 T2 s square plus T1 plus T2 into bracket s plus 1. The highest power of s in the denominator is 2, so that it is also called what? Second order system. Exactly similar, second order system. So I hope you understood how to calculate the transfer function of a RC circuit. In this lecture I have covered 3 problems. First one is a single tank, then double tank, then RLC circuit. Okay, thank you.